The original top steering yoke for the Le Mans 3 is here in front of us on the surface table. As we can see, it's quite an unsightly item. This one's got a fair bit of damage, scratching and dents, and the paintwork has obviously seen some better years. What is also present on this yoke is the mouldings for the handlebar clamps, which on the Le Mans 3 are not actually used, as the Le Mans has clip-ons fitted which are clamped to the top of the fork tubes just below the top yoke here. On the original bike, of course, this is all hidden because the clock console sits on top with the speedometer, rev counter and the various indicator lights, so it's all hidden from view. On my bike, as I'm going to be dispensing with that console, this now becomes open and quite visible with the handlebar clip-ons just down below the yoke there. And really the style is not fitting of the bike I'm building. The clock console is going to be replaced with a Moto Gadget Motoscope Pro unit, a very small LED device that will sit somewhere on the top yoke. My intent now is to machine a new top yoke so I can make something more befitting the style of the bike that I'm actually building. As with my foot peg mounts, I will use aluminium. I've ordered a big lump of 6082 grade aluminium, which should be with me hopefully by the end of this week or early next week. The process I'm going to adopt for machining the new top yoke will be very much on the go. So I'm not going to now document a design on paper and then look to build it. What I'm going to do is work my way through the machining and make decisions on the outcome or the look of the final piece as I go along. To start off that process, however, I do need to get the key dimensions off this yoke because I am intending to still use the bottom yoke, although I may revisit that one later on. So I need to machine a part with the same key dimensions, which is going to be the distance for the fork centers and the offset from those fork centers to the stem center here. The other key dimension I need to be conscious of at this stage is the offset from the position of the fork clamps on the left and right here to the stem clamp. As we can see, there is a height difference between the two. As I'm going to be recording this and producing videos and posting them online as I go, there's always a risk, of course, that I make a monumental mistake somewhere along the way and end up having to bin it all and start again, or maybe even abandon the project. And let's face it, as we're still in the latter stages, hopefully, of lockdown, it's going to be more about the engineering itself rather than necessarily just the end result. My original intention was to use the top yoke on its own to determine the various dimensions, but in fact it's easier to put the forks back in with both yokes and the stem, which gives this nice rigid assembly. Then I can use the forks and the stem itself to actually do the measurements, which will make things a hell of a lot easier. To determine the distance between the centres of the fork legs is a relatively simple exercise. I will measure across the fork legs, outside edge to outside edge, and from that I will subtract the diameter of the fork legs, which is effectively one radius at either end of that dimension. That will then give me the distance between the centres. So rather than subject you to me messing around with the caliper for a few minutes, I've already done that, and the dimension between the two is 214.7 millimeters. The fork stanchions themselves are nominally 35 millimeters, but in practice they are actually slightly less than that. I've measured them, and one is 34.7 and the other one is 34.68, so we'll take that as 34.7 millimeters. So 214.7 minus 34.7 millimeters gives me the distance between centres of 180 millimeters. Determining the offset between the centre line of the fork legs and the centre of the stem has proven a bit more difficult. Ultimately, it's come down to a bit of good old-fashioned trigonometry and the application of Pythagoras. If we look at the yoke, we can see we effectively have a triangle between the 3 points, the top of each fork leg, the centre of each fork leg and the centre of the stem. If we split that triangle into two, so we have two virtual triangles, we have a triangle between one fork leg, the midpoint between the fork legs and the centre of the stem. And that is a right angled triangle. To help visualize that, I've actually made a little paper cutout of a right angled triangle which I can stick on the yoke, and hopefully you can see what I'm now trying to explain. So there we have the right angled triangle sitting between the center point of the fork leg, the midpoint between the two fork legs and the center point of the stem. And as I said, it's a right angled triangle. So we already know one of those dimensions. We know the A side, which is the half of the distance between the two centers of the forks, which is 90 millimeters. The longer side, or the hypotenuse, I've measured, and I've done that in the same way as I did the fork legs. So I've measured from the outside of a fork leg to the outside of the stem and subtracted from that measurement the radius of each. That has given me a dimension of 111 millimeters. So the hypotenuse equals 111. So using good old Pythagoras' theorem, and I'll put it in a caption down below, we know that from Pythagoras h squared equals a squared plus b squared. So therefore we can rearrange that little formula and determine dimension b. And that comes out at 65 millimeters. So I now know the offset from the center line of the fork legs to the center point of the stem. The last of the dimensions I'm interested in at this stage are going to be for the clamping elements around the fork legs and the stem, both in terms of the thickness, so out to the outside diameter for the fork legs, and also the depth. I'm also going to be interested in the offset between the two, the stem clamp and the fork leg. As you can see, they are at differing heights. They're all relatively simple measurement activities which I can carry out with the vernier caliper on the surface table. I'm not looking for super accuracy here. So for depth around the fork legs, we've got just under 25 mil. I will work with 25 mil. For the so the thickness is actually tapered around the edge, but that's coming back at around about 9.6 millimeters. The depth for the stem, that's also coming back at 25 millimeters. So 25 depth for the fork legs and for the stem. We've got round about 9.5 mil thickness around the webbing there. And to determine the offset, we'll just do a very quick measurement of the height. And that's coming back at just over 50 millimeters, 50.5. For my purposes, I'm going to take 25 mil depth for both the clamps, and they will be offset by 25 mil. So the bottom of the stem clamp will be aligned to the top of the fork leg clamp. What I'll do now is I'll capture all these dimensions I've measured, probably use a simple CAD package to document those. And also, as I said earlier on in the video, it is not my intent at this point to have a detailed final design for the yoke. The design itself will evolve as I'm going through the various machining operations. To finish off this video, what I'm showing on the screen here is the outcome of me entering the dimensions as captured into a basic CAD package. So hopefully what we can see is reflective of the key dimensions for the top yoke. Clearly there's still a lot of detail and information missing, mainly because I don't yet know what it is, as I need to think about the design as I progress through machining the yoke. Of course, there's always a danger with doing design on the hoof, but that's the approach I'm going to take.